me ask you guys a question. Well, I'll remind me to ask you something at the end, because there's nobody here. Why aren't you guys here? Oh wait, you are here. The other guys, why aren't you here? Let's talk about a couple other things that we really need to. One of them is exceptions. And it is an interesting and sometimes useful thing. Bad things happen, and you need to be able to react to them. But you want to somehow, we came up with this weird way of forcing you to react to some bad things happening, right? When you try to do something in a computer, can you guarantee that it will succeed? Imagine that I'm trying to read a file from the hard drive, and that tends to be kind of the standard thing, right? What happens if I say, computer, read file a.txt? What could happen? Maybe the file is not there, right? Well, what if I could check that it's there? Can I, now after that, can I guarantee that it will succeed? Well, maybe. The file may actually be on a USB drive, and in the middle of me reading it, you yank the freaking USB drive and I'm dead, right? So when you're dealing with that kind of stuff, bad things could happen. When you're dealing with anything that is external to you, right? Actually, hard drives can fail. They never do, or they seldom enough do that you don't. But when you're dealing with anything external, right, you can't rely on this stuff being available, right? You can yank the USB, you can kick the network cable.
Could it be that it's like an unknown or unsupported file type, or?
When you're reading,
You
you read bytes, and so you decide whether you support the file type, right? For the most part. Most of this stuff tends to do the Unix kind of thing where bytes are just bunches of, where files are just bunches of bytes, so it doesn't matter. But you could also, so what we came up with and Java adopted from other places is what is called structured exception handling. Operations can throw exceptions. So you call a function, the function does whatever it's supposed to do, but it may decide that it wants to throw an exception. And that's outside of the normal flow of control. And then anybody in the caller hierarchy can catch that exception, and then the execution will continue over there. And they can decide what to do.
So it's like raising a flag, like, hey, we got an issue.
Hey, we got an issue, right? And maybe whoever called me doesn't care.
Yeah.
So my boss doesn't care. My boss's boss may not care. My boss's 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 boss will care. Or somebody will care. So it is like raising a flag, right? So to throw an exception, you use the keyword throw.
So the reason why they chose throw instead of like?
Historical artifacts, they decided to call it throw. You throw an exception and anybody can catch it. You're throwing it. If you think of the stack as they're calling me, so I'm down. Yeah. Just throw it up to see who catches it. I'm assuming, but whoever proposed it in the literature called it throwing it, and the name card. I can throw whatever. Normally, I throw some kind of exception. And so we have the exception class. Then, if I know that the code might generate an exception and I want to catch that exception, I would use a block of code like this. I would use a try statement, put braces, put whatever I want to try inside, then declare that I catch different kinds of exceptions. And then in here I can do whatever I want. I can also add a finally clause, and that will get executed regardless. If there was an exception, it gets executed. If there was no exception, it also gets executed. Now, Java tends to want you to declare all your exceptions. There is a big hole which is called runtime exception. But if your function or method can throw an exception, Java will require you to declare it. So in your method, you say throws, and then you specify which kinds of exceptions you can throw. And then you can define your own classes and things that extend exceptions. So let's go do that. Let's create a new package code. Okay. So I have my main. Let me declare static method I'm gonna call it parse static method. God. Static int parse and add that takes two strings and parses them as ints and then adds them up and returns the sum. Does that idea make sense? How can we do that? How can we parse a string into an int? Parse int, right? So we can do int n1 equals integer dot parse int as 1. Does this make sense? Might even work. What happens? The first call, when I pass the string 1 and the string 3, succeeds and I get a 4 printed, right? Now the second one doesn't, and it actually throws an exception, right? When I call integer.parseInt, right, the return should be an int, but it's Joe. Joe is not an int, so I need to do something else. What that function does is it raises an exception. That exception is a subclass of runtime exception because if not, we'll be required to catch it. But does that idea make sense? Since we didn't catch it at any place, then there's a global exception catcher that just dies, prints it and dies. So, what can we do? Well, what could we do? We could try and catch, right? When you start doing this, the hardest part about exceptions is actually figuring out what the heck do you do. what should we return when they pass with Joe and Bob? Or what do we do, right? We can catch any kind of exception, right? Now what do I do? I could do this, right?
Probably, well, I would probably make it an integer and return null,
What do you mean, make what an integer?
the return type.
Oh, like a capital I integer, return null?
Well, just because if you if you entered 2 and -2,
Yeah, Joe and Bob are 0. Right? You get to decide, right? And we can come up with different things that you could do. But for learning the mechanics, right? This is what you can do. We put everything inside a try, right? We catch, and then we do something, right? Does that idea make sense? We could, and you get to, again, decide, we could catch it on main and do different stuff in main, right? We could, since we knew what kind of exception we were getting, we could catch number format exception, right? And say, only if you get a number format exception. If you get something else, then do something. In here, we can use this, so we could do something like exceptions have a get message. So we could do stuff like this.
What's the difference between the get message and the get localized message?
Horrible thing. No. We don't worry about that stuff. One is in English, the other one is not. Localization, right? We are in the US, so we don't care about the world. When you have an international business, right, you have to worry about other kinds of things. But here you wouldn't even get, because you're going to get it in English anyway. So get localized message, put it in English, unless you happen to install your things for Spanish and then you get it in Spanish if your locale is different.
Just like the metric system, we don't care.
Sorry?
It's like the metric system, we don't care.
Yeah. Yeah, it's US. Does that idea make sense? In fact, if we do warning for input string Joe and didn't tell me anything, which is a horrible message, but that's okay.
So do you only know to put these in once you run it and you start getting errors, or should you just be able to kind of know off the bat like, oh, I'm going to need exceptions because...
Well, here's the deal. Let's do this. Will it print something nicer if I just do E? Yeah. Okay. This will call the toString of the exception, and they tend to be reasonably nice. And it printed 0, which is what I returned, right? So, sorry, can you repeat your question? I got lost.
We're saying, like, how would we know that we need to add an exception? Like, are we going to run it through and be like, oh, I got...
Well, here's the deal. Let me define my own exception class, right? I don't know Java class. And I'm gonna say that it extends exception. It's gonna have a constructor think I can do this. And it works, yes. What does super do again? Doing classes, right? I'm inheriting from exception. What does super do?
Calls the parent the constructor.
Calls the constructor of the parent, right? And so you can go look at documentation, but it has one that takes a string and also one that takes the other exception. Because exceptions can be nested. So what I can do in this one, instead of I can throw and know my exception, right? But it's complaining. Why? It knows that I am not handling that exception. I can throw it. Nobody's handling it. I can declare here that I can throw that, right? Ideally, I would do this. I have to declare that I throw it, right? And now these guys become in trouble. Because now Java knows that main is calling this function that could throw out my exception, but I'm not handling it in main. Does that make sense? So I can do either of two things, either actually catch it or cheat. And it will stop complaining. And I get something like this, right? It's my exception, it says bad juju, it tells me where, and it's caused by all this other stuff. Isn't this cool? It's one more tool in your arsenal. It can definitely be misused. It can be misused if you, the misuse is that exceptions should be exceptions, right? It shouldn't be stuff that happens all the time. It should be rare, right? It should be an exception, not normal stuff. So if you start throwing exceptions and using it kind of to really control your flow, instead of if statements, right, that throw exceptions, then that is bad. It's going to lead to a program that's horrible.
So then how do you know when to use an if statement versus a throw exception?
It's called philosophy. So we normally do what we always do in computer science. Teach you the syntax and tell you you're on your own.
So if you get to where you're just doing like bad stuff with a bunch of like if statements, then should you consider maybe I need to just throw an exception?
It's more like there are several different things that you could do, right? What happens if your operation can break, right? Imagine that I'm talking over the network, right? Imagine that we know how to talk over the network, right? And I'm calling somebody on the network, I send him a number, right? I send him a SKU, and they send me back the price, right? Say SKU 123, they say it costs $1, right? I want to hide from the caller how am I getting the price, right? So I just have a get price method, right? You pass it a string from the SKU and you get back the price. That is good, right? Now the problem is, can I trust that I will always get back the price? I'm sending stuff over the network, so I can't really trust that I'll always get back the price, right? The other side may not be there. Somebody may keep the cake. Somebody may keep their power cake, right?
Or they could stop carrying them.
They could stop caring and never answer me, right? I mean, it's like, so what can I do? I could do all sorts of things. Like, what could I do? Well, I could actually create a class that returns two things, a price and an indicator of whether it succeeded or failed or something like that. We tend to do that in other languages. But, right, it's like, how often does that happen? Not very often, right, so you should treat this as an exception, right? That's versus, I don't let you set the price to, I don't let you set the price to something, right? Or where I should probably be returning you a different thing. Or you ask me and I have an empty set, or I have a null, right? I can return null as it doesn't mean anything, right? Rather than an exception. It becomes, what do you want to do? If I don't need somebody to, if I don't want people to catch the exception, then I do a runtime exception. If this guy, instead of inheriting from exception, extended runtime exception, then I do not need to declare that anybody throws it. And Java will not bug me about it.
So, other languages have exceptions as well, or is this like
A bunch of languages have exceptions as well. I have no clue who started it, but Java popularized them. I think they were in C++ before Java, but I don't remember. And they came before maybe Eiffel or Ada or one of those guys. But Java has them, and now every other OO language has them. They are actually fairly useful for I/O, where, well, the file's not there, the network's not there.
basically, so when you're dealing with something that is out of your control, then you will, or you're
Yes.
sort of input that's out of your control, then you're gonna.
Yes, and it's kind of an out-of-band message of communication. I should return normally this. It's also when within a method, if you can think of a reasonable way of dealing with it, then you shouldn't throw an exception, you should deal with it. If you don't have a clue, right, then it's like, oh, talk to my boss. I don't know, talk to the other guy. And that's when you throw exceptions and rethrow them. And it can, there's also a big thing of, should you create an exception for everything, or should you reuse exceptions and things like that? You have a string. Should I just use a string, or should I create different exception classes for every possibility? It sounds terrible, but it is the accepted answer. The accepted answer is create exception classes that just do this kind of stuff for every possible thing. Or for, once you catch something, you start. Yes, it sounds terrible.
So like we made a general method, you know, where it's use type. Could you do something like that where we're trying to like be?
I mean, you can do it with generics. I don't know what would be the.
Yeah, I understand.
Do you see how exceptions work? Yes? We have covered the syntax. That's good enough. Now let's go talk about I/O, which we never quite did. We have been, I/O is input output, right? We have been doing input and output. How do we do output? Print stream, and we call print line and print, right? How do we do input? Int. Create a scanner and we call next int and those things, right? where am I reading from and where am I writing to? I'm reading from the keyboard ish and I'm writing to the console ish, right? Why is the ish? Because I'm reading from standard input, right? System.in. I'm writing to standard output, system.out. Where is that being displayed? Where is that being read from? I don't know. Whoever called me can actually redirect the input and output and have that stuff come from files in the network or things like that. Does that make sense? You have seen that stuff, right? You have seen input and output redirection? Yes-ish? No? Let me do. Can I do this? Let's do. Well, let's create a new one. Call it IO new package. I'm gonna do system.out.println hello world. And I managed to mess up the simplest thing. I need a main. Or do this. Right? Super simple stuff. Now let me go generate executables. How can I do that? I'm gonna change this to IO. So now I can do probably in here. Where is this stuff? Is in projects. Yeah. I mean here I can do gradlu build. What this will do is build a jar file. I could do it with just the class by itself and use Java-C if you guys would rather we do that. But if not, this will eventually this compiles all of the class files and things like that, and it creates a jar file that contains everything and creates stuff in there that says this is the main class. So I can do java -jar and execute that guy. Oops, no I can't. Never mind. Good. Okay, I can do -cp for adding the class, and then do com.okaram.io examples. No, I can't. I lied to you. What else is build? Distributions. Is that the one that has this stuff? No. God, that's horrible. Okay, but I can do this. It actually does this. Yeah. God. It creates classes, so I can do in here java com.okaram.
The ls command typing? What's that do?
Sorry?
The ls command?
ls is list files, so it lists the files.
Lists everything in the folder.
It lists the folder, yeah.
I got you.
No. Is there anything? Yeah. It's not creating that guy. Why? Ah, because I put it inside collections. Now it's outside. Maybe. This builds. And so I can do cd.
What's exclamation there?
Yeah.
Oh.
I've never seen that.
Ah, God. You guys don't use the command line. Learn that stuff.
I'm working on it.
It's a very good idea for you guys to become as proficient as you can, but the bang, the exclamation point, executes the last command that started with that letter. So bang dot means do the last thing that started with dot. That is, go back in my history and find the one. So
Okay.
the more you learn those things, the easier it is to use the command line. That's why the more proficient you are, the easier your life will be forever.
It's a good resource to So if you want to play around with it, kind of just
There is
Yeah, there are like classes on like Git.
There is, yeah, TLDP, the Linux documentation project, is not true. This stuff is not Linux. In fact, this is a Mac, which is not running Linux. But a bunch of that stuff is similar. There is a bash. That's this one and another one. Bash Guide for Beginners. Bash is the actual command interpreter that's reading your stuff and doing stuff. So this is probably a good first thing. There is and I think I put it in like module 0 or something like that. There is Coursera. Somebody has a command line course.
Code Academy? Yeah.
One of those guys, yeah.
There's like Udacity has like a course on it, I think.
Code Academy. And so that's horrible. Now they charge you for it. It used to be free. But for the most part, those things will stick if you like read a little and then try, right, and play with them and then kind of force yourself to do it. It's a lot easier on Linux because it kind of forces you to do a little bit of that. On Windows, you get Git Bash, which is fairly decent, so there is no. On the Mac, you just open your terminal and you have Bash. This is where I was, right? Ha! Now it's running, right? So if I type Orlando, it will say hello Orlando. Right? Does this make sense? Now I can do I'm redirecting the output, and so it finished. It never printed anything on the screen because it created this other file. And so if I cut it, it will print the output. Does this make sense?
What is cat? Just read.
Cat is just, yeah, read the file, show it on the screen. Does this make sense? Now, what happens if I do this? Less than, so it's gonna read it from there. And now it's gonna print to the screen, so it's gonna print hello, hello Orlando, because what's in that file is hello Orlando. Right? And I could, of course, do both of them. So now I have t2.txt. By the way, the other thing that will make your life easier is always use tabs. Tab in bash auto-completes your things. So you do lste tab, and that types the rest of the stuff for me. Which is very useful for not typing stuff, but it also means that you don't make mistakes. When you're trying to type a big path, I don't know about you, but there's no way in hell that I'll type that stuff. But if you tab, then you auto-complete the keys that you need, and then that makes it a lot easier to actually type. Does this idea make sense? So we can redirect input and output. This has been there since forever, since before Unix, but then since Unix, and then it's actually there on Windows and MS-DOS, right? Windows, you can use git bash and get bash. It also has an old command line thing called cmd.exe that runs the old MS-DOS commands. Is anybody here old enough to have used MS-DOS? Yeah. There is now PowerShell, which is actually not hideous. It's a really nice scripting language and command line interpreter. If I didn't know bash, if I hadn't been doing bash for 20 years, PowerShell I think is a nicer language than bash, but I've been doing bash for 20 years. So those things come naturally. Especially now that PowerShell is not Windows only. It used to be Windows only, which is kind of. So this idea makes sense. You can redirect input and output.
So the less than sign, again, why did it make hello?
The less than sign says read the input from here instead of from the keyboard. So the less than says read the input from the file called test.txt.
Because first, instead of printing it to the command line, you printed hello Orlando to that file. Then you read in from that file and said hello, what you read from this file. So it said hello, hello Orlando.
Okay, just read the one.
The first one, right, I wrote the output to that file. So I wrote hello Orlando to that file.
Okay.
And then on the second one, I am reading from that file.
Gotcha.
And
So
then,
you can go to that file, edit it, and you can still read it.
yes. So name.txt.
Where is the one that says hello? Okay.
Unix people tend to use Vim or Emacs. They're both horrible text editors, but they are programmable. So if you spend years on them, you can program them to do whatever the heck you want when you press whichever key you want. So people who spend lots of time tend to do those things they actually like. It is amazing the amount of abuse that humans would get used to and actually like. Both VI and Emacs are hideous as text editors, but so if I have test.txt where I have Orlando Alfredo, I could run this thingy, sorry, name.txt with name.txt, and that would print that stuff. Could have different files and run it and script it, right, and run it different ways, save the output to other places and things like that. On the other hand, that is still reading from standard input, right, and writing to standard output, right, ish. Let me actually go change and do one more thing. Let me explain one more thing. What is this that we're passing to main? We're passing an array of strings. Not a string of arrays, an array of strings.
Got dyslexia.
Yes. Where is that coming from? Those are the arguments that are being given to me. So we could do for string args. In fact, I'm not even gonna do this anymore, and I'm just gonna print that stuff. Does this make sense? Let's build it again. Now I'm gonna pass it arguments 1, 2, 3. And these strings separated with spaces are gonna go as the args array. Does that make sense? I pass them here, separated with space, they go here.
So is it by default just an empty?
By default, it's an array. If there's no default, but if you don't give me any arguments, then there is 0 arguments. It's default-ish. Yeah. You can ignore it, and that's what we have been doing.
Oh, what's the length of the array then?
However many arguments you put there. There is eventually a limit, but you'll get tired before the computer says.
So you can't add more arguments to the array without taking grounds?
Well, I'm done typing the command. This stuff is going to be executing. Now I can.
But it doesn't retain that? The 1, 2, 3?
No. When I call it, it's a completely different, right?
Okay.
It could. My shell retains it if I press the up arrow key.
Okay.
But that's bash. All that magic you do with Git, this is the stuff, right? You're passing a command and you're passing the other stuff separated with spaces, right? If you want to include spaces inside your things, then you can use quotation marks or single quotation marks. And that's bash, that's not. And there is, I don't remember what's the difference between single or double, but either one of them works. Does that make sense? Yes. So good. So, when we are reading, right, one of the really cool things from Unix was this idea of, wait, a file is just a bunch of bytes. Doesn't have anything special. It's just a bunch of bytes, one after the other, right? And actually, if you don't want to go up and down, right, and rewind the file and do things like that, then I can consider it as a stream. It's just a bunch of bytes, one after the other, and all you can do is read the next byte from it. And then you can build everything from there, right? And then that stream abstraction works for keyboard, just a bunch of keystrokes, one after the other. Each one of them generates a byte or 5, right, depending on which keywords you have, and that's it. It can be network. When I'm talking to somebody over the network, I just send a bunch of bytes, one after the other, and then I can read bunches of bytes, one after the other. And there is no good way for me to just skip some or something like that, so I need to kind of read all of them regardless. And so this idea of a stream is a very useful abstraction. It can work for whatever. There are more complicated things for, well, what if I have a random access file where I want to move within the file? But the one that we tend to use all the time are streams. That idea makes sense. Cool, now let's go talk a little bit about Java. And we need to cover exceptions before that stuff because these guys can throw exceptions. Now, we get one of the standard problems with Java. It is now an old programming language, right? It became popular in '95. It is 22 years old. Not older than you guys, but close, right? For some of you. It has a lot of cruft. It has a lot of old stuff that's still around because, well, you don't want your old program to stop running. And so, so Java had stream classes, and so input stream, and a bunch of other things, and it had then reader, and finally scanner. Scanner is what we tend to use, right? And input stream, basically, you can only read 1 byte. That's all you can do. There's also one where you can read a bunch of bytes one after the other, but it doesn't know that's an int, right? It just reads a byte. And so if you want to read characters and parse it and things like that, then you use a scanner for text-based input rather than binary-based. What we can do is create a file input stream which reads from a file in a file system, and that you can, and they messed up. There is a Java class called file that doesn't declare files. The file class talks about files in a folder, talks about the metadata for the file, not the actual data for the file. And so the actual data for the file is a file input stream. You can create one by passing it a name. And so what we could do, let's do something. Public void cat file. ish. I create a file input stream, create a scanner, and while it has more input, I call in.nextLine and then I print it. Right? So shall we do it? Let me do this. Print stream. So we do it to out. Right? Now, oh, it's complaining. Why? I have an exception that I'm not handling, right? I can declare that I throw it. Forget about it for now. There are other exceptions actually that I'm not catching in here. But
So is there an exception because it needed a file path that we hadn't given it or anything?
no, when I pass the file path, it may be that that file path doesn't correspond to a file.
So Java knows that.
Well,
essentially?
when you run it, when you call it and you pass the file, it will go look to see if the file is there, and if it's not, at runtime will throw an exception.
But it hadn't like.
But it knows that it could throw an exception, so it forces me to do something.
Okay, that's what I'm
with it.
saying. So
Yeah.
So it'll kind of nudge you in the right direction. And that.
It will force you unless it's a runtime exception. If what you're throwing is a normal exception, then it will. What you're throwing is a runtime exception, then it will not. Now, we can do this. Static. And it's complaining again, so I can do throws exception. Or I could go handle, and we can play with how to handle the exception. But I can say test.txt, t2.txt. I'm passing file names, and this should print their contents. Is this cool or what? Maybe we can do stuff like oops. Did something break? Ah. Does this make sense? Here's my code. Basically, if I'm not going to be doing anything special with my file, once I create the input stream, that's it, and then I can use it as if it was system.in and system.out.
So
no clue. It depends on your IDE, not right. Like we can find there is actually when you do run edit configurations. This is your configuration, and one of the things that you say is program argument. I know how to do it on IntelliJ because I sometimes use it, but it depends. What IDE do you have?
Well, I've never, I'm still, very new, but I've never actually passed arguments to the main
Yeah,
method, I don't think,
you can by doing this, right? If we were gonna, let's see, what do I have? Oh, let's do cp star.txt home. So this is my home folder on the Mac. Once I run it, what happens when I run stuff is that I have no clue which path it runs from. So I'm gonna list complete thing. So I can put as an argument this whole thing, ls star.txt. So I can do name and then I can pass another argument. Say test.txt. Run it, maybe it gets one configuration. No.
I got it to work.
Okay.
Okay, thank you.
Sure. But yeah, I think my problem was that I ran the wrong thing. I think this is it, maybe? No. Oh well. It's an IDE issue. Normally, what I do when that starts to happening is say, oh, switch to the command line, and over here I know what it is. So I wouldn't even know how to, like, if you want spaces, how do you separate them or so? Probably quotation marks work, but I don't know. I cheat. I use Linux as my IDE, and so I just really need a text editor. Although I'm getting more and more used to actually using IntelliJ, but so those are the kinds of things we can do with files and file with file input streams, right? And a file output stream is the same-ish as a print stream, except that a print stream is different. File output stream is a kind of stream, and then a print stream. So you would need to create a print stream from the file output stream. God, no, not you. Yes, you. Oh, it is a, no, it's a filter output stream. Oh, but you can directly create it from a file name, so it just works. Just use print stream, and what you got is system.out-ish. Does this make sense? We have a little bit of time. We have 5 minutes. Whoa, tons of time. About 10 minutes. Play a little bit with the file class, because this is a file class represents the metadata for a file. Represents a file or folder, but it's path and size and that stuff as opposed to the contents. You can create a stream and go read the contents. But so it's a representation of file and directory path names. So what kinds of things can I ask? I can ask it for its permissions, can execute, can read, can write. I can ask to compare with another path name. I can create a new file.
So, like in the example, can you go back to IntelliJ real quick? So like where you did your cat file and you said string file path, if we were to instead do like file,
I could pass a file.
name,
Yeah.
do it that way.
Yes.
Then instead of reading that text document, you could do the give permission.
No. You cannot. Right? When you create a file input stream, it would still read from. When you are doing file input stream f equals new file input stream, that would still read from the file, other than the permissions and things like that. I could have stuff like so I could do file f equals new file from this path. I could do this. Let's see. We can do let's do fun stuff. I'm gonna pass it a file, right? And so what I'm gonna do is first of all print f dot get name, and then call print full path on f dot get parent file. Is there something? Probably not. So if f dot get name hopefully this will allow me to work. So I'm gonna change this. I'm not gonna be doing any of this or reading my arguments. I'm just gonna do print full path of I said that I'll pass a file. So this would print, hopefully, test.txt, then query, then users. And it died. Oh, okay.
So you don't have to put an exception
So I
on
could
there.
do, rather than this, I should do, that makes sense. If, yeah, I got a null pointer exception, which is a runtime exception. Try to do stuff on null.
Okay.
If f different than null, that is the right condition. Because the root doesn't have a parent, and that would probably work even on.
So in this case, you chose to use an if statement except
That
chose exception.
it shouldn't be an exception, right? Because eventually you're gonna reach to the root of the file hierarchy.
And that's what I say, since your main one has an exception, that kind of is under the umbrella, so it will catch it.
No, I'm not throwing an exception. I'm never throwing an exception because I shouldn't, right? If you pass me null, then the
I mean, previously though.
Previously, I was doing something wrong. I had a bug in my code.
Okay.
But it could have said, oh, I'm gonna just throw an exception and still terminates, but that would be horrible. I mean, you can. Doesn't mean that you shouldn't.
I was trying to see like if since you have the exception on your main, if that would kind of be like under the
That
umbrella
exception
that-
in main, I need it because I cannot necessarily create this guy,
Okay.
right? I need it for creating this file.
Okay. But so it's separate from your other methods.
It's, yeah,
Okay.
in fact, I could do, could do file f equals null. Try and I don't do a thing. And then I don't need to do this throws exception. The line that is throwing the exception is this one.
Need a single.
Maybe, yeah. Thank you.
It's just easier to do the other way where you close exception instead of doing the.
It is a horrible practice. But I tend to do it many times in this class just because it saves me from tons of time. In reality, no, you shouldn't do it. Sometimes a man's gotta do what a man's gotta do, but you probably shouldn't do this. It's just in a class I have a few minutes to explain a topic and I may not want to go. So in a class like this, I tend to do tons of throws exceptions, just because. In fact, you shouldn't ever do throws exception. You should actually figure out which things you can throw and declare them, because they are documentation for the next pool sub that's gonna come look at your code. And you know who that next poor person is gonna be, right? You, on Friday afternoon when you want to leave. So, you want to do it the right way, so you don't. Does this make sense? I think we can leave it there for now, and we can, just for fun, we'll talk about folders and stuff next class. Let me pre-ask you something. I'm gonna ask it also by email so that I can get everybody's opinion, because not everybody's here. I'm gonna be out on the week of finals. Ha ha ha. I'm going to AWS reInvent, which should be a ton of fun. So I wanted to ask you if it is okay for the in-class people to have the final on the last day of classes rather than the official date. Sound reasonable?
When's the last day of class?
29-ish, 26, 20 something or another.
That not Thanksgiving?
No, Thanksgiving is really weird. Thanksgiving happens on the 22nd or something like that this time.
So there's 1 week after Thanksgiving.
There is 1 week after Thanksgiving in November, because Thanksgiving is the 4th Thursday in November, not the last one. So Thanksgiving is actually on the 23rd. It is the 4th Thursday in November. It's not the last Thursday in November. Almost always it's the last one, but
So the whole week we don't have class from Thanksgiving.
there is no class for the whole week of Thanksgiving. And then we come back the 27th and 29th is the last day of our classes because we meet Monday, Wednesdays. I think December 1st is the first day of finals and then they go over all the whole week.
Can we just do a review on the 27th then?
Yes. Sounds reasonable. And for the online people, I will, if you cannot come, then I'll have an online thing that goes over all that week. Because it's online and you can do it whenever. Cool. I will see you guys eventually on Wednesday. We'll talk about more. Today's Wednesday. So I'll see you guys on Monday. And I will probably end up adding one more assignment just to get more practice. But the last assignment